welcome everyone to our latest Zero Carbon Mine webinar. Today we've got Adam Price and Jacob Bennetts, who've both got presentations around simulation for in mining decarb, sort of different focuses. But yeah, as always, we keep it fairly casual. So if you've got any questions, then throw them in the Q&A box, and the presenters will try to get to them as we go along. Otherwise, we'll have questions at the end. We'll have Adam go first, and then followed by Jacob. So yeah, I'll hand over to Adam to run through his side of things, and we'll go from there.
Beauty. Thanks, Brett. I'm going to share my screen, and because you don't want to look at me talking, and show you some stuff. I'm with a company called RPM Global. So before I go, RPM Global. So if you're interested in the software that I'm going to show you, that's where you can go to find out even more. That's my last plug. Let's jump into the software. I'll share my screen. There we go. All right. So this is the software that we wanted to run through today, the simulation software that we supply. It's called HallSim. It's a discrete event simulation software product. Let me just run that back. And what that means is that we're modelling all of the equipment on the mine site as individual pieces of equipment. We started building this software about 10 years ago, and there's been a lot of development that's gone into it over that 10 years. But the reason we started developing it was because there was nothing really like it on the market for mining. So simulation has been around for a long time, but building models of mining operations has been pretty difficult traditionally, because things move all the time, and there are some calculations that we need to do to be able to model the way that haulage works on a mine site, and we'll get into more details on that. But what I might first do is to run you through this particular mine site. So this is our electric mining operation. I'll just spin it around a little bit so you can see our massive wind farm and solar farm up this end of the operation. So it's really important that any energy coming into our system is green energy. So we've got all that catered for over the hill there. But on this mining operation, we've got a few source locations. So down in the pit here, there are some sources. And you can see, if we zoom right in here, the loading units, loading trucks. You'll notice that when the equipment's driving around, that it has different symbols above it, and that indicates basically what it's doing at that time, so what state it's in. So when things are being loaded, you'll notice a yellow symbol. Green is travelling empty, and then this will change to a sort of a blue colour. That'll be travelling full. And this purple colour is waiting. So we can do single-sided loading, double-sided loading. With regard to all the material movement, so different materials that will perform differently when they're being loaded as well. We model spot time and at the source and spot time at the dump, all that sort of stuff that you expect if you're in mining when you're trying to model the way that a haulage system works. We don't stop with the loading equipment. We also model crushers and dumps and stockpiles and those sorts of things. But we found with the move to electrification and green energy on mine sites that we've been able to really get involved in that area as well. So we already had the simulation software that was modeling the way that a mine works. But over the last few years, because our customers have been trying to answer a lot of questions in that space, we've been focused on converting our trucks to electric trucks and hybrid trucks as well. So we, as well as battery electric, we do hybrid, so hydrogen or diesel hybrid equipment, so that you can model any of those different variants that will be coming to market someday soon. Underground space, there's a few options available, but we're still sort of waiting for it to arrive in the open pit space. I'll show you some of the other infrastructure that we've got. So our trucks all have batteries on board. So we have dashboards to interact with the simulation while things are happening. I'll just show you this over here. So all of our trucks in this model are battery electric trucks. And what this dashboard is showing is the energy level of that battery for each of the trucks as they're driving around. So when the trucks are driving, if they're going uphill or doing their normal work, they'll be using electricity. And we're modeling the usage of that electricity as the trucks are driving around. As they're driving, we've got some opportunities for them to get energy back on board. So we have these trolley lines here around the place. So there's a couple over here where the trucks can actually get energy back on board. There's another one over here on this ramp as the trucks are coming up into this dump. So yeah, we model trolley systems and charging batteries from trolley systems. But in this model, we've also catered for static charge locations as well. So when the trucks are driving, if they trigger a recharge event, which is all configurable, then they'll drive over to a recharging location and they'll start charging up. So in this location, we've got a few different trucks. So there's two trucks recharging, and there's 2 trucks that are waiting to recharge at the moment. And if we look at the truck itself, if I can find one that's actually recharging, you'll see the battery level go up. So yeah, it's all working as you would expect. Any questions so far, Brett?
No, not that I've seen. Like, yeah, if anyone's got any questions, please, yell out.
please yell out. Other things that we do. So one of the reasons why modelling haulage is so tricky is that the trucks don't drive around at a constant speed, and it's not the change in speed that they have as they drive around is not just a normal acceleration deceleration like you can kind of do if you're modelling a factory. The speed that the trucks travel at is dependent on the rim pull curve from the manufacturer of that truck, the payload that they're carrying, the gradient of the road that they're traveling along, rolling resistance, all of those things that many of you would have seen in other modelling tools. So all of that is accounted for while the trucks are driving around. We also do things like have cornering speed settings so that the trucks will slow down around corners as well. So you'll notice these trucks travelling up the hill, when they're full of waste, are travelling a bit faster than the truck coming down the hill. So all of that modelling is done in the background. So some of the things that our customers are learning about their electric fleet of the future while they're modelling in HaulSim, things like what the availability is like for the trucks using different charging techniques. So our customers are able to compare trolley systems and static charge locations, or they can use both in the same model like we're doing here to understand what the impacts are on the availability of that equipment. Obviously, with diesel being the most prevalent on mine sites today, we understand very well how that works, and we don't see too much of an impact on the trucking availability. But with these new ways of getting energy on board that we're looking at, they can have an impact on the amount of time that the trucks are able to be used for moving dirt around the place. As
Just
well
one
as the truck
question,
side.
Adam, like,
Yeah, mate. Yep.
like as you said earlier, well, there's, you know, electric trucks or whatever aren't necessarily available out there in the market at the moment.
Yeah.
You know, I know you can model it, but I suppose getting to know whether or not how realistic what you're modeling is, calibrating that, you know, I suppose how confident you are what you're simulating is fairly accurate to what we'll be able to achieve, particularly if there's equipment that doesn't exist yet.
Yeah, so what a lot of our customers are doing are basically using, they're either working with the manufacturers and getting information from them about how they expect the trucks to work, or they're using, they're making their own trucks. So in the software, we're able to basically take an existing truck. I'll show you that. So we can take an existing mine truck of a certain size and then turn that into a battery truck. So the same rim pull curve as what it was. And many of the trucks are diesel electric. So I suppose the base case is that the truck should perform at least as well as a diesel truck. And then we can throw a battery into that truck. The best way to do that is to look at the power of the diesel engine that it's replacing, and then can configure the battery so that it works in a similar way. So in our trucks, we can add a battery. So this is the size of the battery here. We can configure the usable portion of that battery. So we can trim off the bottom and top of it if that's what the chemistry of the battery is going to give us. We can give it a maximum charge rate. And we can also, when the simulation starts, have a range of values across the trucking fleet so that they're not all starting full or empty. We can set a minimum threshold. That's the point at which the truck will go and try and find somewhere to recharge. If it gets below that point, it'll go and find somewhere to recharge. We can enable charging events or not. So if we're just looking at trolley, then we turn that off. But we can also capture energy through regenerative braking. So when the trucks are slowing down or going down ramps, we can put that energy back into the batteries. And this is how we model our usage. Some things that we've been working with our customers on this as a way to configure the truck. In the latest version, we've also got variable recharge rates depending on how full the battery is as well, after getting feedback from our customers that was also required. So yeah, you can basically take any truck, Brett, and turn it into a battery truck.
Yep, no, fair enough. I suppose it's when you actually, once you start getting these bits of gear out there, how well it calibrates and how well it performs compared to that. I think we had a question from Kevin that's probably a similar sort of vein. How well does the modelling match the actual environment, and how easy would it be to remodel the simulation if required? Yeah, like how long did it take to rejig simulations and rerun them? Is it a fairly quick process?
Yes. No, we've tried to make it really as simple as possible. So if you wanted to draw a new road, so we've just been in the run screen, really. There's a build screen over here, which has got a bunch of tools that allows you to move roads around and make changes, add new sources and destinations. And I think we just showed you how to configure a battery. So there's no code involved with our software. We tried to make it. I'm a mining engineer, and I wanted to make it easy enough for my peers to be able to use. So we didn't want to turn them into coders. We wanted it to be accessible to the people that actually had the problem to solve. So yeah, so it's different to the other simulation software that you can get off the shelf. I suppose the one part that we've been talking about is the haulage equipment, which is really important. How the haulage equipment is going to work is is one side of the puzzle that we're trying to solve, but the other side is around the infrastructure side. So another use case for simulation is trying to understand for the electrical engineers that are supplying the power to these trucks, and that's a pretty significant amount of power that needs to be available for them to recharge at a recharging location when they're drawing, say, 2 megawatts or whatever from this location, and then another bunch of power from the trolley systems. We can also capture exactly when those events are happening at the mine site, so we can build a typical day at a mine site, and then help everybody understand what the power requirements are going to be at that operation. And as you can see, when we run the simulation, there's a change happening all the time. So there are trucks joining trolley systems and getting off trolley systems and charging and not charging. That hasn't been normal at most mine sites previously. It's been a lot more steady state, the demand on power. So being able to model that and then give that feedback back to the other users involved around a mine site, especially around the electrical infrastructure side, has been quite powerful as well. It's allowed them to help to understand what sort of designs would be required to fulfill the capacities that are required. Another thing that I haven't really shown here is that it works in underground operations as well. So we don't discriminate. The lights stay on no matter what environment we're mining in. Underground's somewhat more complex when we're modelling trucks driving around because of all the tunnels involved and the infrastructure involved. But we model all of that as well. So trucks have got to stop and wait for each other. If they're if a truck's travelling in the opposite direction in a tunnel, and we're modelling everything again at that mine site, all the infrastructure as well. So we model all passes and loading areas where trucks are getting loaded and so on and so forth. We added some extra functionality with our batteries recently for the underground operators, so that they can better model battery swap type situations, which seems to be the way that they're heading with that smaller equipment. Yeah, so you can model all of that as well, but trolley lines and all the rest of it is also available in the underground operation. Just doesn't look quite as nice as the open pit operations, which is why we use this one for demonstrations all the time. All right, was there any other questions there, Brett?
No, I don't think so.
I can keep talking all day.
Yeah, if you've got anything else, otherwise, we might.
No worries.
Wrap things up, and we'll jump over to Jacob when you're sort of happy.
No worries. Well, just quickly on the reporting side of things. So while we're running the model, we're recording what's going on, and we can send that out to our reports. And the reports tell us, they have a summary of everything that's happened on that simulation run. So for every truck, we've got the amount of electricity that is used and consumed, and how much it's generated as well while it's travelling downhill, how much it's moved. We've got the same sort of thing for loading units. We can also see how much time trucks have spent recharging, as well as all of the other activities that they've been doing as well. So that gives you a sense of how much usable time there is for the simulation, and how much time they've spent doing other things. We can also see how much material's been moved around the place. But for the infrastructure guys, one of the nice things is being able to see exactly what's happening with your infrastructure. So here we can see for our trolley lines exactly how many trucks are using that trolley line at a time, what time that started and how long that lasted and all those sorts of things. And we do that for the trolley lines and the ancillary locations, so the other recharge locations. And there we can see how many trucks are actually charging and how many are waiting to be able to go and charge as well at any of those locations. Working with Liebherr, we also added the functionality to be able to restrict the number of trucks that charge on a trolley line. So the amount of raw that each truck can take from that trolley line is also configurable, which allows us to stop extra trucks charging at the same time. Yeah, so there's a bunch of stuff that we've done for various customers over the last 4 years or so to enable them to model basically anything that they throw at the software now, which is really good. I might leave it there and let Jacob have a go, unless there are more questions to answer.
One just popped up from Kevin.
Yep.
Was it? Are you using other renewables modeling software to feed into your system, resulting in sizing the renewables and energy storage for the site? So I suppose whether or not the renewables modeling is separate to what you're doing with the demand side.
Yeah, we tried to stay away from being electrical infrastructure experts. We're providing the details to feed into other models. We've sort of stuck to what we do best, which is haulage and modeling how the trucks operate, which is really quite important. We can see that there's a big gap between like an average demand that you might get across a mine site versus the minute by minute changes that are going to happen. So we're focused on the detail of those minute by minute changes, and we feed them to other models. There's a lot of extra, there's a bunch of losses and things that need to be modeled at a site's when you're looking at the entire site, and we'll leave that to the electrical experts. But happy for our stuff to feed into those models, absolutely.
Righto. I suppose the level of detail you've got there, you should be able to input that into other models.
Absolutely. Yeah.
All right. Well, I might hand over to Jacob. Jacob, if you're still there. Yep. I think you're on mute.
Yeah.
There you
Thanks. Thanks, Adam, and thanks, Brett. And thanks everybody for jumping on the call. Am I coming through okay, Brett?
Yep, no, you're fine.
All right, cool. Yeah, let me know if there's any weird audio or camera issues. But yeah, thanks for everybody. So, look, today I thought I'd talk a little bit initially around just general simulation and decarbonisation. And then we talk a bit about the product GreenNet, which my company's developed and has a lot of similarities with stuff that Adam shared. So I'll try not to double up on, especially on the haul truck stuff. But yeah, just going back a step. I don't have any pretty slides, but my team and I were engaged several years ago now to help out Rio Tinto actually in their decarbonisation strategy for rail. And I do have a background in rail, and we do a lot of rail work. But we also, my consultancy also does a lot of simulation work, so general simulation. So looking at anything from capacity modelling of a network or a workshop, looking at different kind of bottlenecking exercises and more generic simulations. So yeah, we've been doing that for a while, and I've had a history in When we got onto the decarb side, though, and the first question we got asked was, okay, well, how big's the battery going to be for I want to get my diesel asset and rip out the engine and put a battery in. How big does it need to be? And that was kind of like, again, this is 3 or 4 years ago now. People are really starting to be like, I need to come up with a plan to decarbonize, and I've got all these diesel, moving assets, trucks and trains and light vehicles as well. And that question, how big does a battery need to be, or should I go to hydrogen, or how big would a hydrogen fuel tank need to be, or should I fully electrify a network with overhead power lines for these moving assets to get off the diesel? These questions sound simple initially, and you're like, okay, well, we'll do some very basic calculations, and we'll say, well, this is the amount of energy you used in your asset, went from A to B, and then you've got potential energy. Let's say you're going braking or going down a hill or something, and that you can get some regen, and there's like some spreadsheets going on, and it's like that's your answer. That's how big a battery needs to be. But as you're probably aware of, and Adam alluded to it, is an actual operation, whether it's a mine or any other kind of logistics like a rail network, or anything with moving assets in a big industry, or even a small operation. It's complicated. And when we're looking at decarbonisation, we're looking at a more constrained problem where running diesel assets, we've had this luxury of always being able to refuel it at a reasonably acceptable time, depending on the size of the asset, could be from a couple of minutes to 30 minutes, depending. If it's 3 trains, it might take a bit longer but everything's kind of within that bound, and we don't typically treat that as a major constraint on an operation. But when we go to batteries, we've now got this issue with payload. So I'm adding a lot of weight to an asset, and I've got only so much energy, and the charging to get that back up to full is quite constrained. And so we really want to know pretty much second by second what would happen, and not just give me one sample route. And this is kind of what we saw, is that people do these calculations with one route from A to B and say, well, that's an average route, or whatever. And that might help you kind of get a rough idea of how big let's say, going to batteries will be, or how much hydrogen you might need to use. But what happens when you're looking at that holistically, like a whole site, a whole operation? So I've got now a ton of fleet that are going to interact, and they're going to stop. And what happens when I charge? I'm queuing, and I've got to wait, and that's consuming energy as I'm waiting. I've got thermal management systems that are consuming energy. And when I'm braking, what's the efficiency of that braking, and how much can I actually capture? And all these things are going to play into the questions that the people at the heart of it are really trying to answer. They're actually trying to say 2 things. Physically, like, is it feasibly possible? You mentioned before, Brett, some of this technology is not here yet. The best we have is, what the manufacturers are telling us about this new equipment. Some of it is in prototype stage, which is great. But yeah, we're going to know physically what do you think we can do, from a physics point of view, and from a electrical infrastructure point of view. And the second question, and maybe the most important, is that how can I do this in the lowest cost way? Like, how can I spend the least amount of capital and have the least disruption to my operation? Because whatever you're moving or doing, if you've got delays there, that's going to add up to costs in lost revenue, in some form or another. And there might be construction impacts as well. So when I'm building this, what's the easiest way to build new infrastructure that has the least disruption? So as you can probably imagine, and this is probably not new to anybody that's in this space, just answering simple questions at a high level isn't really going to give you confidence to go forward with a particular scenario or particular plan. So we started doing this. We built some very advanced stuff for Rio, and we realized the tools off the shelf weren't really there to do holistic sites. I think Holcim has some, they kind of got onto that journey, and from that whole trucking point of view, Adam's shown a really pretty good view of that, I think, of the considerations of the trucks. But what if we want to go further than that and look at trains, or what if we want to look at, let's say, LVs or buses, and what if we really want to look at the impact of a whole operation? So, does that cycle time impact other areas of the supply chain? And yeah, that's why we came up with GreenNet. GreenNet is a discrete event simulation tool, and a physics engine. So again, a lot of similarities with Holcim there, but we have dedicated rail models that have full rail physics and proper deadlock prevention and simulation. Sorry, and the routing logic and whatnot. We also have a basic haul truck module as well, and we have other motor vehicles. We don't have ships or airplanes yet, but we can kind of play around with a few different assets and then interact all those. Let's say you're in a mine, go to the crusher, we could simulate the crushing plant as well, and we could look at the amount of energy required to run that crushing plant or a processing plant. And yeah, we can kind of go a little bit broader, which is nice. But yeah, that's a bit of the story. I'll dive into some examples. So yeah, you can see what I'm talking about. And there's just so many questions to answer, I think, is the thing. And that's, again, the power of simulation. Even if it's not, perfectly based off historical data, we do a similar thing like Holcim, where we can use actuals from existing assets to calibrate or adjust models if we know they're going to be similar. Yeah, then we can look at a lot of scenarios and try to answer those questions about how do I decarbonize in the most efficient way. So I'll just dive now, still share my screen. Where are we? This one. It's got my notes there. And I'll dive into a little example that I did find sometimes, just to show like how you can do something quite simply. I last year was on a trip to the mining expo, and yeah, looked at got to go across from Vegas to Utah very briefly to go to this national park, Zions National Park, and I noticed there that they had these zero-emission battery electric buses, and I instantly started doing a bit of reading and had a look at that decision that they'd made. So they've got these shuttle buses running up and down the canyon. There you can have a quick look at that kind of map I found on their website. This shuttle takes passengers up, thousands and thousands of people. I don't remember how many per year, but it's a large number. It's very popular, a tourist destination. And I thought, what a great example of something where you've got these issues with these diesel buses. People don't like the smell in this beautiful, pristine part of nature, and the apparently the aircon didn't work very well, and they're a bit slow and clunky, and so they, the government in this case made a decision to look at battery electric buses, and made that switch. So now their whole fleet is battery electric. That got me interested. So I thought, what if I drew this network out? So GreenNet has a network builder. On these little lines, I've added my little points here around where the stops are going to be for the bus as per the map that I found. I also did some digging and I found the bus that they were using from this company here. So I put in the specs of that bus into GreenNet, and I thought, well, how big? Let's answer that question. How big would the battery need to be? And this is a fairly straightforward operation in the sense they pick up passengers They run from 7 a.m. to 5 p.m. every day, pretty much most of the days of the year, unless it's a lot of snow, I guess, or something like that. And we simulated that. So we start off with the logical kind of blocks of what the simulation is going to be, put in our specifications. I've got a few parameters here with some of the delays, battery size, etc. We also ran the same thing with the diesel bus, and I'll just kind of play that back there. And yeah, I was just interested to see would it work essentially. So you can see the little asset zipping around there. That's kind of fun. But the really interesting part is when you look at these metrics. So we look at, for motor vehicles, actually like 5 data points per second, so it's quite granular. For trains, we just one data point per second, where we're calculating what gear they're going to be in, you know, what the forces are going to be, what the braking effort is, and energy demand and all that. So I'll load up an example of that. Let's load up this one. And have a look at some of these metrics. So what we're mainly interested in is the battery. And if we look at the battery there, we'll see. This is the charge. We put a 600 kilowatt hour battery, or a bit over, I think 690, which was the biggest that they had on offer, and we saw that the battery dipped like that. You can overlay the elevation that was going on as well, and have a look at that. You can see it. If I zoom in a bit, it might look a bit nicer. If I zoom into a bit further, you can see the elevation profile. It's a bit too much zoom. Yeah, on that, and that was basically told us that, you know, it told us that the bus could go up and down all day with that battery size. Told us what the kind of charging infrastructure would need to be for their fleet when they're charging at night. You can see there, you know, from 5 p.m. to, looks like they finished charging about 11 p.m. on that day, a bit different on that day. And we can look at things like passengers moved. We can look at time usage of, a particular vehicle or a group of vehicles, you know, what they spent their time doing, waiting around, charging, going up, down, etc. So we can get a lot of metrics out of that, but really we just wanted to answer that question, was, you know, well, this one has no cost of diesel, because it's a battery electric. If I load the diesel, we can have a look at, put a dollar figure to that and have a look what that might be, versus the emissions that the diesels are putting off. And I just thought that was interesting. The other thing that I did was just look at a bunch of battery sizes to see that I hadn't overspec so I did what we call like a bulk run or optimizer, where we just do a bunch of simultaneous runs to check what the battery size could be. So these are a bunch of failures where the certain buses ran out of charge. You can see the 400 kilowatt hour, that's what that number is, didn't work. And then 500 kilowatt hours, and from then up, it was a bit of a sweet spot. So a very simple example, but again, this would be one of your first passes to say, well, should I even bother? You know, is this possible to turn this fleet into a fleet of electric buses? And I guess if we look back at the specs of the bus, you know, a range of options there. I'm not sure which one the government there chose. I know they used the 60-foot, and they had a 520 to a 690 battery. So I'm not sure what modelling they did, but I guess our modelling says that any one of those sizes would have been perfectly fine. The 520 would have been the cheaper option, of course, and that comes back to that cost. You know, I don't want to overspend as well. I'll jump quickly. I know we're should be all right on time, but I'll jump into, I don't know if people have any questions. I know there was a bunch for Adam, so we'll get to those in a second. But if you have any for me on the bus stuff, otherwise I'll switch to a rail demo. which was interesting. This is for those that are familiar with Western Australia. That's Port Hedland and the Pilbara. We sketched out. This is not anything proprietary, but for those that are familiar with these locations, is the FMG kind of mine setup, rail network, that is, and we go and draw a model like that by hand, or we can import the file from the client if they have the data. And we wanted to make that as easy as possible, similar to what I think Wholesome allows. Go in here and just kind of click and draw out a new network like that, and we can import elevation. We can give things curves and whatnot like that if we want. Yeah, and play around that. This rail module is very detailed in the sense of it's accurate in terms of a proper signaling system and things like that. We can put in obviously locations of destinations where we're going to send things, different passing track and whatnot. Once we've got that set up, we can go do a similar thing where we're interested in answering questions. Those questions might be, how, you know, in this case, do I need where are my charging points? That was one of the most critical points. Can I get away with charging just at the port? Can I get away with charging just at the mine? Do I need to have charging mid-track with assets moving across? So these are all the things that we looked at. So there's a bunch of parameters in there, looking at some max charge rates, some battery sizes, how many locomotives are on the train. And then, you know, there's the logic, like we said before, around how it decides on where it goes and whatnot. So what we, you know, again, I'll just press play just to see some fun things moving around. We've got all the wagons on the back there. Nice and zoomed in. But yeah, it's really the interesting thing is these metrics. You can see the train cruising along there with a bunch of wagons. We do model all the forces in each single wagon as well. So a lot is happening every second, and what the braking distances need to be for these 2.5 kilometre long trains with 30,000 tonne, you know, they're pulling along. Yeah, you can see I haven't quite put my line on that one very well. It's on the access road, not on the rail line. But yeah, we understand the grade they're going up and what they're doing, and most importantly is that payload. So when I'm looking at this production, I'm looking at tons getting loaded at different mines here and getting then put back to port, and I can compare that like between a diesel operation with no, you know, maybe static charging, or something where I've got moving charge, etc. And I'm trying to inform the business of what's the, again, cheapest capital, and what impact would I have to these tons back at the port. I've got some things around utilization of certain sections. Yeah, a big one is group demand. So I've got, in this case, a lot of different assets moving around, and you can see this graph has kind of grid load instantaneous from different locations. I haven't broken this up by location. This is a system total. But, you know, that's not preferable if you're supplying energy to that network that has massive swings from 20 megawatts to, you know, 4 or 5. And you'd have to then look at, well, can I smooth that out? Or is that just the nature of what a dynamic system with no schedule is going to be? These trains run when ready, which means they don't have a schedule. They just go, go, go. And if something breaks, it breaks, and then they keep going, which means they're going to be charging at very random times. You know, so if I expand that out a little bit from 40 hours or whatever, or I think I did the 7-day simulation, again, you can just see that there's this quite random nature that you want to be aware of when you're thinking about all these questions for decarbonisation. But I think the moral of the story is, for me anyway, is that with good simulation tools and a good approach, you can consider